Um, hey everyone, my name is Anton. Yes, it was a long time since, I think I was here last time, pre-COVID time, and this time, after COVID, it's the first time when I speak publicly, and if my colleagues wouldn't be so persuasive, probably I wouldn't speak even today. Hi, my name is Antons, and I am working for the company EPAM Systems, which is specializes on the digital products and solutions. And here I will be talking today about some infrastructure stuff, and I will be presenting for you the tool that we call Hubctl. I am the maintainer, and myself and colleagues of mine helping to maintain the Hubctl, which is open source, something that we have been developing for a while. I think 2017-ish, approximately, when we started. And if you want to contact me, these are my contacts, basically. Actually, I think the most interesting GitHub usually, but so, what is the Hubctl? Apparently, I personally have done DevOps consulting and advocacy, I don't know, since ages, and there are things that I started to notice that kind of repeats again and again, and then we decided, okay, there's no tool which addresses it all, so we decided to build one. Right. So, however, today I will be speaking about, I'm super biased towards the Hubctl, but apparently what I will be speaking about is something that I believe is universal. It comes from the experience, and it's you don't have to use tool, but you can follow the principles. Right? And I think these principles are a little bit more important. So, first of all, a couple of things. So, when we decided to build the tool, so we wanted to make it infrastructure as code centric, because infrastructure is code something that works. Right? So, I hope in 2023 we don't have to tell that infrastructure is code, this is nice, and so on. So I hope it's more or less mainstream now. So nevertheless, if you have any comment, just grab me after the talk, or we'll have Q&A session. So one more thing that I will be talking to you about reusable components, and why this is a good thing. And I'm a little bit again biased towards the reusable components. And last but not least, the open source software. It's also important. It's because today we basically cannot do the commercially viable development, and the infrastructure is called like it's kind of ish development. So we cannot do it and be commercially successful without relying on with a certain edge on the open source. So that means that whatever tool we want to present to the public, it must be open source. So apparently I doubt if you can scan this QR code, but maybe later. There are also with the small letters some links if you are unable to scan. I doubt if you can read it, but nevertheless, I think this presentation will be distributed. If not, then I will find a way how to distribute it. Okay, so I need today I asked this guy called Hudi, and he will help me today. And this is my co-presenter today, right? So the Hudi just built a very nice application. Right? And the Cody is modern developer, and he knows that if you build it, you run it. Right? So he is not. He already knows the DevOps principles. He will not overthrow to the systems administrators and say, "Hey, here is my wonderful code, and just please figure out how to make it stable and run it." So, so what Cody will do, he will actually create some CI/CD pipelines. He will actually containerize his application because it's 2023. If you don't do serverless, you probably do containers. He decided that Kubernetes is a good choice for him to run. So basically, he will put. He already wrote some deployment code for the Terraform or for the Kubernetes. And of course, he will use the version control system to commit the code, to communicate through the things, because he already had done a very good job by putting some infrastructure as code already into his application. And it's pretty much, he's pretty smart. So, here is the thing. So, in 2023, I still would like to talk about operation enablement and the wall of confusion, right? Because there is still something that Cody, who is a developer, who created a wonderful application, who already wrote many things, so he is ready to own the application in production, right? The problem is the application is not ready. Right? There are many things that Cody must think about before his application will be deployable. First of all, how many components inside of this application? Is it just one? Is it living in a vacuum? I doubt it. Right? It probably has some dependencies, some databases, caches, volumes, and so on. It might be dependency of another application. Right? So in order, if you want to deploy it, you need to kind of coordinate with respect to all dependencies. So then a few smaller things which are less obvious. Okay, how about secrets distribution, like database passwords and so on, identity and access management, ingress traffic, right? How about this? His application probably will need some public domain name with a validated SSL certificate and so on, right? How about monitoring, right? It's a very, how to say, extreme. It's probably part of extreme programming to run something in production without proper monitoring. Basically, and last but not least, how about the configuration drift, right? It sometimes happens. I've seen it once in my life, configuration drift, after I deployed my beautiful infrastructure as code, right? Somehow it was 2 days ago, but it was, I promise it was just once. And actually this is not the same. I can continue this list forever, probably, right? There are things that we need to bake inside, or we need to teach Cody to bake things inside. The only thing that I am really afraid that, how to say, if we will not have, if Cody will not think about all this, he probably cannot fully claim that he owns the application in production, right? On the other side, if he will think about everything up front, he probably will never done his coding, because he will do all these important things from the infrastructure perspective, right? So, otherwise, there is torture like flames of hell in operations, right? I promise. So, any cure is there any cure to the Cody? What we can do, right? So basically, before he will dump his head over the laptop, what we can do? First of all, let me ask the question. Just past the previous slide. To pass these other concerns and so on, and do the other stuff, like how many tools could you need? Right, there is no right or wrong question, right?
Many.
But, sorry?
Many.
One, well, basically, yeah, I spoiled my previous slide, yes, because there is a dilemma, right? We can use one tool to rule them all, right? And I've seen it many times. I think this is cultural thing, right? Many companies prefer to use just one tool for everything and be happier. And other companies decided, okay, how about be more pragmatic and use more tools? Basically, I kind of biased towards the second approach, right? Nevertheless, I was in many occasions, and in many recent occasions, when there was a single tool preferred because of many reasons. Probably, how to say, the people believe that, well, first of all, their learning curve, they don't want to have the zoo of the technologies, right? Fully understandable, right? And especially when there are, like, they want to spare the brains of their systems administrators, right? They teach them the one tool, let's call it Terraform. It's by far my favorite tool, and this is why we'll put some spikes and. But not because, like, just because I love it, right? Yeah. So let's call it Terraform, right? Because you can do everything with the Terraform, and yeah, and pretty much like all the previous concerns can be achieved with the Terraform, right? And yeah, then the other thing, it's the resources when you use the one tool are a little bit easier to integrate together, because there is one life cycle. In the Terraform, if you're familiar with the Terraform, this is infrastructure as code that has the modules, and you can link the modules together, and then it will figure out all the dependencies between them and deploy it. Right? It's very easy to do because it has the certain dependency resolution cycle. It's always the same, and yeah, it's relatively easy to do. Yeah, but and Terraform is a wonderful tool. Where it fits. Yeah, anybody wrote anything with Terraform recently? Anyone? Oh, okay. Fewer than I was expecting, but nevertheless, anyone recently wrote anything with the null resources of the Terraform? Yeah, Terraform has this nice thing, like they have this all resources, everything like covered by the Terraform until something is alien to the Terraform, and there is no escape from that, right? In order to make it somehow happen, they created something like a null resource, and actually, then it's kind of hack that you can try to put inside. And the only problem with the null resources, it's hard, at least my experience, right? For me, it was hard to debug everything, and then it was always broken. Yeah, and some time ago I wrote a lot of things with the null resources, right? And this is an example where you can solve the problem with the Terraform, but sometimes the problem solution, how to say, does not really work. Like you waste more energy to solve the problem with a tool that doesn't fit for this concrete problem rather than gaining value after you receive the solution. The only advantage you will have one tool, right? 20 years ago I wrote everything for Java. My favorite thing was 20 years ago, and what we've done, we took the C++ application and rewrote it for Java, right? Because everybody thought that Java is the only language that you must use, right? So today I am polyglotic. I write in multiple languages because some microservices are easy to write in Go, other in Python. Well, if you can do both, it's very tempting not to, right? So, and then we decided, is it bad, really, approach? If maybe we can Well, it's actually a bad approach, like when you do infrastructure as code, right? Because, how to say, when you have multiple tools, right, there is one thing which is good. When we do the DevOps or infrastructure as a code, there are brilliant tools that does one thing brilliant. Other things they're doing less brilliant, right? Then, if you want to use the multiple tools together, which is obvious approach sometimes, then you kind of starting to glue the tools together. Right? You glue it again and again and again, and these integrations easily become broken. Right? So, and apparently, what we also figured out, just by observing probably mostly our performance, right? There are certain pieces of infrastructure as code that one developer, like cloud engineer, let's call these people like that, can support. Why? Because he will be busy not writing the tools, but basically integrating the other tools together. They have different life cycle. It's not always very easy to integrate, right? If you don't believe me, try to run Docker build from Terraform, and then push the image, and then schedule some Kubernetes deployment with a pushed image. Yeah, good luck. And yeah, but we all do this, right? So, and other approach, right? If you don't use the single tool, you have to integrate all together. You have to write this Docker build. Then you write some shell script that will interact with the container registry, with make some kind of templating for the Kubernetes deployment manifest, then deploy it, then wait, validate everything is ready. It will be a lot of code, and it will be sometimes it becomes messy, right? So, and what I wanted to say, like I have seen in many occasions that there's beautiful cloud engineers. They were stuck, and they were not able to create more components, something that gives the value, because they were always fixing broken integration between the tools. This is worth to mention, right? So, so we decided to create a tool that will solve this problem. So basically, so we would scratch our heads and dump it across the head, so you don't. Right? Мы заморочили, чтобы вы не заморачивались. Pardon my Russian. So, and let me give you a little bit more. So, sometimes applications look like this today, right? There are apps, some applications, and then containers, right? And basically, my previous slide has the following thing. So it depends how many tools you need in your DevOps toolchain. It depends on how much of deployment you want to manage. If this is only the app and containers, then tools like presumably this is Kubernetes, right? Just presumably, right? Because like they kind of becoming synonyms, right? Then you probably will be fine with some kind of application, some simple Kubernetes deployments, and that's it, right? You probably will need the Helm or Customize, and that's it. Easy, right? And yeah, but then basically, if you want to manage also Kubernetes together, right? Kubernetes nodes and autoscalers and so on, you will end up to measure the virtual networks of the Kubernetes and kind of deal with that, all the service meshes and so on. You will need more integrations, right? And this is when you probably will go out of just what Helm or Customize, the beautiful technologies, go to technologies to deploy any code to the Kubernetes. It will start to fail for you because, yeah, it's a little bit exceeds what they do, right? You will need to add extra tools. There are alternatives, and there are things that you can add, but you already started to add the tools. This is what my message. If we go further, right? So you want to provision VMs, right? Then how about the Gestos and the VM? So you already need more tools, right? Then at this level, you're probably thinking about Ansible already, right? And we can go further, right? How about like if you go beyond, you wanna have something self-hosted, right? Anybody using the private cloud or anything like that, or running some Raspberry Pis and to watch movies or host some blockchain node? Yeah. So basically, yeah. In this case, you have to think about all this, right? So that means that depends on what do you think is part of your application. Is it only this? Is it this? Is it this? Is it this? You will need more or less tools, right? So, since we will start to move to the tools, right? Then what we learned from microservice development, as I mentioned, right? It's very tempting if you can use multiple programming languages, you can use them together, right? Like just one microservice will be written in one language, another one in another, right? Because it's more, it's easier, better, easier to maintain, easier to write, and so on, right? So from my previous slide, right? It depends on how much things you manage. It's actually smart to split all your deployment into the multiple components. We call it components, but sometimes it can be called modules, sometimes else packages, but we call it components, right? So in this case, I will give you an example of WordPress application. It's a kind of CRM application written in PHP. It's a web application, so it has the database, and in front it has CDN, content delivery network, something that will cache HTML, distribute all binaries, and so on, right? It will do some this stuff, right? It will also manage some domain names for these applications and some other goodies, right? So right now, what is important, right? In my mind, it's if you can split your applications into the components, it's better. Then you can manage each individual component, right? If it's and that's easier, a little bit easier, rather than to manage everything as one single deployment unit, right? Because in that case, your code, I wrote it once in my life, maybe twice in my life, when I put it just one monolithic deployment, and inside of the deployment, the code was so tangled together. So to apply one simple change, I just couldn't for a long time until I will figure out what's broken. Yeah. So, but if you can split into the reusable components, then it's a little bit easier, right? And I already mentioned one word, reusable, right? This is one of the things that if you have introduced the component, it can be relatively abstract, right? Similar to the microservices, right? So the microservice, especially in the data plane microservices, can be relatively abstract. So what we learned from the microservice development, how the microservice people actually build in the components, microservices. Very easy, right? If I don't have Cody on this slide, but if imaginary Cody will build one microservice and I build in another, and what I can do, we can agree about data contract between microservices. Just agree. What will be our integration? What parameters I will pass to Cody, and what parameters Cody will pass to me, and then I can create mock, stop his microservice and do my development. Then Cody will do the same, and once we're ready, we just remove the stubs. And if in ideal world, if we did not break the data contract that we agreed with, then it probably will work. right? So how about why we can do the same with the infrastructure? Right? Why I can't just create a database component that will read some things from the environment, something like okay, what are the storage requirements for the database? What are the some RAM, CPU requirements for the database nodes and so on, right? And so on, right? And then it will pass these parameters to the component. It will run the I don't know, Terraform apply or any other execution. Then it will read outputs. For example, MySQL connection string, and it will pass to the WordPress application to say, hey, you have dependencies from the database, I brought it for you. Right? Just take this connection string, and now you know how to configure your data source. Then just do your deployment. Once you're ready, just pass as the output to the next component your HTTP endpoint, so CDN could start to do his caching stuff, right? And so on, right? And once it's all deployed, then there are some kind of final outputs, something that will be meaningful for the users. Like now you can go over there and you can press, you can open this WordPress and start to do shopping in our brand new e-shop. Yeah, right? So this will give us one slight advantage, that actually the different environments, right? And this, what I was speaking about, this is normal process where we have the environment, right? And in other environment, might have small deviation from that, right? How about like if this is my Kubernetes cluster, for the development, I'm totally fine running my database on containers because it's easy to wipe out if it's misbehave and so on. If there is something and start again, but I would think twice to run my SQL, my relational database in containers in production, right? My first approach will be to take the different component of MySQL. That will be not for the containers, but for it will deploy to Amazon as RDS database instance, managed instance with some little bit. That will be a little bit more durable, my deployment, right? And I will rely on that. And by the way, if my first deployment was MySQL database was deployed with the Helm chart, because it's a go-to technology for deployment on Kubernetes, I can change the technology to the Terraform because Terraform is go-to technology to deploy some VMs and some cloudy stuff, right? At least for me, right? Then, but if I'm not, but both components will implement the same data contract. So this guy will, I change the components, and this guy will continue work. He even will not notice that something goes slightly different, right? In this case, I can create, and these variants can be a little bit more, and so on, right? This is quite a good advantage to have everything implemented in a very nice way. So, if you are in the Terraform, you swear by the Terraform, and what technology? How to say? When I mean like different components, it's better not to do everything as the one monolithic deployment of the Terraform apply. I want to use 3 times Terraform apply in this case. In this case, there is a tool called TerraGrant that can help you, that can wire together all the tools, right? It's actually our competitor, yeah, TerraGrant, but it's okay, yeah. So the only thing that is left is actually to put all these components together into the sequence, because we will need to figure out the dependency between the components with the respect, and pass some parameters from the environment. A little bit more, right? Because if we live in the real world, then we need to have some kind of interaction with the third-party system. This may be ITSM system that will trigger the deployment, or we will need to send some callbacks after each component of the deployment. So it would do some ITSM stuff, right? We need to manage we need to manage the deployment state of all components together, right? Because there may be configuration drift, right? We need to do more stuff, right? Like encryption, like and so on, because deployment state is the often vector of hacker attack. It has everything inside. So you need to do this. You need to protect against the abusing the automation, so somebody would, and so on, right? There are many things like, yeah, there are many things. I placed some of them, but yeah. So let me go a little bit more to the weeds. I hope I still have a little bit time. But yeah, now it's a little bit about Hubctl, each tool, but apparently I've seen this many times. When I was helping to my clients without actually using the Hubctl, because they have their own preferences, and I love my customers more than my tool that we're building, right? So, and I kind of started to repeat the same and again and again. And this is the essence, I guess, of my talk. That it's easy. You probably, whenever you start to think about the deployment using the principles that I mentioned previously, you will end up with something similar. First, you need to have them. You will end up with a manifest. And for every component, right? The easiest part of the manifest can be Terraform variables if you use Terraform. For us, we created some abstract manifest that does the following. So because we want to create, and this manifest will actually define the data contract. What parameters will be this component expects, and what parameters it will produce for anybody else. And then it also has some kind of capabilities, something that may pass from the environment, something like access requirement, something like, okay, to be able to deploy, right, I need to have AWS access and Kubernetes access, right? Both, or one, right? And then we will need, and then these environments usually pass it through this kind of access credentials are passed through the environment, right? So somebody needs to inject it. Then you will need input parameters, output parameters, and this is what we do a little bit our specific stuff. We have the verbs. The verbs are very similar from the Kubernetes, and actually we borrowed this idea from the Kubernetes. Our verb is deploy and then deploy. Deploy is to install infrastructure, and then deploy to tear it down. Yet there are many words like backup and so on verbs that you can bring, and the verbs that we don't know about. The backup is the optional verb that every component component may implement or may decide not to implement, because not everybody needs backup. But deploy and deploy pretty much everybody, right? So then this is how our data contract looks like. Yeah, the beautiful YAML. Yes, yet another markup language. The reason why we stick with the YAML, not with the HCL, TOML, and so on, right? How to say everybody understand it? It's super easy to generate programmatically. Right? So whenever you need a little bit more dynamic, it's super easy to generate programmatically. Right? And this is approximately how it looks like. We have the component. The component declares I want Terraform. This is a JS bucket component, right? Something that will create storage in the Google Cloud. Right, and then it says that I want to know the bucket name, and because it will use Terraform, I will speak about this later, right? We can map the facts that we're receiving into the variables, and this is the easiest way how to pass the variables to the Terraform, just by declaring the TF-var variable. Yeah, some parameters can be, how to say, empty, right? So, and then Terraform will do its stuff, and then we will read the bucket location from the Terraform, and then we also have some kind of things to read the sensitive outputs, because sensitive information should be preserved in the state separately, right? Otherwise, yeah, terrible things may happen. So. Then the next thing that we have, and this is the easiest way to integrate template engine. The easiest way to implement, right? Especially like if you do Kubernetes deployments and you use something like customize. The one like I love customize. I love it less when I need to apply some templates to it. I know that customize is not made for the template. It's fine, but yeah, apparently yeah. And actually, I love Helm, Kubernetes Helm, unless I need to do some overlays for Helm, right? So, but anyway, I've seen it several times when even the customizers are using templates, right? So we also brought templates to the customize, and yeah, this is more or less pattern, but pretty much everything can be templatable. And yeah, apparently, if you cannot pass to the deployment scripts as an environment variable, you can always render the template, right? Even if you don't want to use TFR variables, you want to create variables renderers. You can create a TFR file from the template, right? Yeah, and last but not least, then we run the deployment. There are several tools that we have the first-class support, and these tools we have been using. If you need, if you want us to build something extra, just let us know on the GitHub and so on. Yeah, we will be happy to. And yeah, these tools we just historically working with most commonly, and then we decided how we're going to build the tool. So the most simplest one, and this is our analog of null resource of the Terraform, the shell support. Right? You can, whenever you want to deploy something super custom, you can just define two scripts, deploy and undeploy, and then we will render some templates. Basically, if you need some templates or consume some environment variables, and you're done. Super easy to do, right? And yet there is also possibility when we use. I will speak about this later. The hooks, and next guy is the Terraform, right? Basically, just drop some Terraform scripts into the manifest, and then basically you don't need deploy and undeploy scripts unless you want to do something super specific and you don't like what we do. Then just drop deploy script, and then we will go back to it, right? And this is basically if you use TerraGrant. You will pretty much do the same, actually. Yeah. The only thing that you probably will need with the TerraGrant, you will need to apply some logic to do before and after deployment of the Terraform, right? Some kind of Terraform deployment, because Terraform is declarative, right? It's how to say yeah, to do some kind of imperative logic, I prefer you to move it under the pre-deployment and post-deployment hooks, right? There is one exception. It's Terraform is sometimes Terraform. Not every resource that you deploy with Terraform are idempotent. That means that if resource is not in the state, you attempt to deploy with the state, it will always fail. So there is also hook for the import script, Terraform import script. Right. Yeah. Next thing, customize. Another one technology like deployment to the Kubernetes. The customize basically drop the customize or customization file, and then yeah, then basically pass the parameters. Or, by the way, you can drop the templates. This is my favorite thing, just to drop the templates of the customized file. What it will do, it will read the parameters, which are key value pairs, do the substitutions for the templates, creates the fully valid customized template, and then run the template. And the other parameters can be passed as the environment variable, something like target namespace of where to deploy as the Kubernetes and so on, right? And pre-deploy and post-deploy scripts are also there, right? It's yeah. We do a little bit extra to the customize. It's worth to mention. Kubernetes has customize is not very always nice to the all Kubernetes resources, especially some exceptions like Kubernetes namespaces and custom resource definitions. So we try to do some updates to the customize. We basically treat, so we have the concept of owned resources by the component and shared resources by the component. And the namespace is one of the example of the shared resource. Even if components will create the namespace, and very often the customized script has the namespace inside, right? Whenever you will try to undeploy this component, it will drop the namespace, and it break all other components that coexist in the same namespace. Right? So if what we do, we try to a little bit update the customize and treat some of the shared resources separately. For example, when you undeploy the namespace, we will still keep it. When you undeploy the component that creates the namespace, we will still keep the namespace. We do the same with the custom list of definitions, right? Because deletion of the custom list of definitions can drop many pods that users created after the component has been deployed, and this is not what you want, right? Probably, right? If this is exactly what you want, just drop some extra stuff to the post or pre-undeploy your hook, right? Helm chart, right? Yeah, we pretty much manage the Helm. We can download the Helm from the repository, install Helm to the target repository, and so on. Yeah, it's pretty much all done. Yes. The only thing that you need, just drop the value file and drop some parameters, well-known parameters, like where we need to find the Helm chart. If you don't like how it works, you be my guest and write your Helm fetch, Helm install logic, and so on, right? Yeah, it's recent addition is ARM, Azure Resource Manager, right? In this case, just any kind of JSON file, and then the parameters. The preferred way for the parameters is just the ARM param. We kind of thought, okay, there is no ARM param in ARM templates, but we thought, oh, it's so nice in Terraform. Yeah, we need to add these things. It's because inputs, like how to say, inputs for the ARM templates to declare in another template. It sounds a little bit strange, but most of my inputs for the ARM is just the values for the parameters. Then let it be the environment variables. Easiest way. Right? And last but not least, whenever we need to also hook the development lifecycle, then Makefiles. This is our we support Makefiles. We stopped our integration with the customly built applications there, but yeah, it's okay to add. All these things are actually managed as the extensions, and actually it's super easy to add more, right? And it's super easy to write custom extensions as well, right? So apparently, yeah, and this is the breakdown of our component, how it looks like. It's basically the component. It has the inputs and outputs parameters on the meta level. Then it will take the parameters, render the templates, capture environment variables, and then establish connectivity when it's demanded by the component, and run the automation. And yeah, I forgot on the previous slide, we also support scaffold because we love scaffold. Yeah, and then it will also execute the hooks and that connect also as the callbacks. Yeah. And yeah, apparently the only thing what is needed, once we have one component, then we just need to put all these components together and write a little bit more YAML file to declare the parameters that will be on the stack level. So from here we have the section, section of the components. Here we write where to download the component, because once the component is reusable, it's okay to put it on some kind of virtual control system, so it would be accessible. And the components can have the dependency between them. Right, and then the parameters, we write the parameters that will be passed from the environment inside of the right? Yet there is one thing, right? Not every parameters must be as part of the infrastructure as code, and this is where I will a little bit contradict with the GitOps presentation probably, right? And we believe that some parameters, sensitive parameters, or some parameters that should be never pass inside of the manifest because it will be stored in the Git. Then you can bring it from the environment variable, right? Yeah, one of the parameters, like if you disagree with me, just commit your Amazon access and secret key from your personal account, right? Or GitHub access token, please. Yeah. Yeah. So and last but not least, basically then for every component that is deployed, regardless what is technology inside, it should have the single interface to deploy. Right? Yeah. In our case, it's just one tool. It's 3 steps. Init to be able to download, that will download all the components, configure it to apply all these configurations and resolve the dependencies, and then run the deployment. Do you have a few minutes? Yeah, okay, yeah. I'm almost there, but yeah. So now the last question is how about the deployment process, right? Can this be run from the automation? That's most frequent question that I'm asked. Like, yeah, actually, this is important thing to remember. Whatever you build, just to run something from the automation. There is one thing: once you have more tools than one, right? It's you need to manage all these tools together, and you will end up like at least usually the components are broken, like not because the components are bad, but just it's different versions of the tool, right? You need kind of like agree about versions of the tool and what versions are allowed. The easiest way to agree just to bake it inside of the Docker image, right? It's also friendly for the automation, right? We call it toolbox. We have pre-baked images, and you can do the same, right? And then, so the first step in the pipeline will be actually at the start it will download the toolbox image. It also makes all CISA happier because they can review the Docker images and see and inspect it against some vulnerable software or unauthorized software and so on. So this is okay. Then the next step is initialize. Basically, what it will do, it will you need to download the file. This is the deployment manifest file with all that tells all the components. Then it will basically look at the components, look at the dependencies, resolve the dependencies, and download components which are not yet downloaded. Right. In this case, it's a good idea. At least this is what we converge it to in the one repo store the components, and the other repo just store all possible, like how to say, templates. We call it stacks, but or blueprints or whatever we call it. Right. It's on the one side you have library of everything what you can deploy. On the other side you have reusable components. Yeah. Yeah, and then you need to do the configuration. This is on the configuration side. Once you resolve the dependencies, you also sometimes you go outside of your pipeline to interact with the cloud services to make it ready. Maybe make some additional callbacks. This is the way. This is the time when we need to request the domain name. Right? Whenever we deploy stack that requires the domain name and user doesn't bring one, we have some domain names that we can assign to the stack. Right? We have a service that you hit to request the domain name. It will give you domain name for I think it's 72 hours. After that, yeah, you can. It will be like normal domain name, yeah, basically. Yeah. And then you can, and basically after that you can replace it with your own domain name easily, right? And so on. This is just an example of external services that you need to agree with, right? And there are more. And last but not least, the deployment. The only thing that you need to do is actually you need to during the deployment keep the state of the deployment outside always, so the other engineers can interact with the state as well. Whenever there is infrastructure ready for the deployment, then basically the facts about the deployment, right? Especially if somebody interacts with your deployment, like maybe another deployment, and so on, right? It will query the state about the parameters, learn the facts, learn the state, is it deployed or not, and basically will know how to configure the application. This is exactly what we do once we deploy the infrastructure. Then we need to deploy the applications on top of that. We just query the state about the facts what we deployed, and then we start CI/CD pipelines normal for the normal applications to appear on top, right? How many more minutes I have?
You should like 5 and then questions.
5 minutes and then questions. Okay, good. Because okay, understood. We started late. Okay. So just to repeat myself a little bit again, just remember what I said. Things that we believe is true, and this is my personal belief, is that the reusable components are good. They are for good with us. And then the only thing that you need for the reusable components is the automated integrations. Right? Often, if you know exactly what you're building, it's very easy to build for you. Right? And then basically, you need to, and then the deployment, basically. A couple of things about Hubctl. We do not replace any automation tool. Right? We just help it to manage and actually help DevOps engineer to focus on the components and or on the stacks, but not on the how to glue together things that just doesn't work together very well. Right? Yeah. Java developers, if you are here, if you remember the times before Spring Framework, you will understand me. Right. So then, yeah, basically from the reusable components, this is probably the best thing that that we actually advocating for, actually to stop doing monolithic deployments. There is how to say, one of the most scary things that I experienced in my life when you have live users and production system, you run Terraform plan and it says, oh, actually, you know what? I just updated my Terraform provider. It now detects a couple of more attributes. So I want to destroy and recreate 60 of components of your production system. Right? And there is no good solution for that. The only thing that I was able to think of is actually to limit the blast radius. That means just if you can do Terraform apply for a few components in controlled way, then and then do so on, or split the Terraform states at least, and then do some and try to inject the attributes by hand. This is sometimes also done, but in this case. But always when you modify your Terraform state by hand, you risk to lose it all. This is why probably this is why I prefer to mess up in this case with the smaller states rather than with a state that consists of 300 different resources inside, and so on, right? So the the best way to limit blast radius actually are the components, right? So then the automatic integrations, yes. Once you have the multiple components, you need to glue them together somehow, right? So TerraGrant, Pulumi, Juju from Canonical. Actually, a new beast in the new kid in the house. CDK for Terraform can be also the choice. The only thing that you will do is Ansible, by the way, yeah, can do the same, and often used as the driver for all these integrations. The only thing that you will have to do, you kind of whenever you will do, you will start to pretty much recreate what I just showed it in the previous slides. Yeah, just be ready for that, right? But say, yeah. And yeah, last but not least, you need to give to the user simple interface to deploy, right? Otherwise it will not work. Yeah, it doesn't have to be always web. we actually I have my own history with the web, like to build the control planes to develop through the web, but actually engineers sometimes need also the flexibility, and the best flexibility is CLI. This is why probably CLI is not dead. And yeah, CLI is easy to build, at least, right? Yeah. And yeah, I'll just keep this slide. I think demo time is not. I'm not ready for the demo time. Yeah, we don't have time, and yeah, the only thing that I would like to tell to you once again, if I'm super biased towards our tool, we do all of this, right? And it's pretty much, it was a lot of work, right? So, and now I think I'm ready for a Q&A. Anything, please?